In this video, we're going to talk about what happens when you have momentum going on that is in two dimensions. So far, everything that we've done has really only been in one dimension because it's just like a cart going along a straight track. And so that's just one dimensional. Well, what happens when we have more than one dimension? The first example is of a mine car. And the mine car is moving along a track. And the mine car has a mass of 510 kilograms, and it's rolling along at a speed of 0.5 meters per second on a horizontal track. Then a 150 kilogram chunk of coal that has a speed of 0.85 meters per second is coming down, and it's going to leave the chute and drop into the bucket. And so the question is this going to make things speed up? Is this going to make things slow down? What is that going to do with it? And in addition, the chute we know is a 25-degree angle. So in class the other day, we talked about setting up what we called IF charts. And on our IF charts, we have the velocity on the y-axis, and we have the mass on the x-axis. And we just kind of set our own increments, and we just want to count by whatever we want to count by. This is kind of just like making a rough draft before you start an essay. So we're just kind of making a rough draft, seeing what's going on, so that in a minute we can make an equation. Okay, so first of all, we have a cart of mass 510 kilograms. I'm just going to make a length of 510 kilograms, and kind of a random length, but that's what I'm going to have. My other piece that I have is the chunk of coal that is 150 kilograms, so I'm going to make that smaller. Now, they are both going in the positive direction, so that's one thing. They're both going to be above the x-axis because they're both going in a positive direction. The cart is going at a speed of 0.5 meters per second. So I'm going to, again, kind of random, but put an increment here for 5. That's how fast this one is going. It's going at 5 meters per second, and we've got 510 kilograms. So our momentum is mass times velocity. So our momentum is the area of this. Now we have another thing going on, and that is the mass of coal, and it is actually going faster than the cart. It is going at 0.85 meters per second. And so once again, we have this much area, which is its total momentum. Now they are going to hit each other, and the coal is going to go into the cart. So now we're going to have a total mass, and I like to put mine together. Some people like to keep theirs separate, but I'm going to have 510 kilograms. And so since they're sticking together, I'm just going to draw them right next to each other. So this is 510 kilograms here, 150 kilograms here. And the question is, what is their final velocity going to be? Well, remember we had a 0.5 and we had a 0.85. And again, they're random, but I'm trying to make them somewhat in relation to each other, somewhat in proportion to each other. So, 0.85 is not quite twice as big as 0.5. And so the question is, well, how much is this total mass going to go now? Well, what do you think? Is it going to go in the positive direction or the negative direction? Well, it has to keep going in the positive direction because both items are going in the positive direction. So it's going to go in the positive direction. Think about, is it going to make that cart slow down, or is it going to make the cart speed up? And some people might think that it makes the cart slow down because you're adding mass to it and kind of making it heavier, and that's going to slow it down. That would only be true if we have friction. Since we have it on a cart and its wheels are spinning, we don't have any friction there. So we're just going to assume that there is no friction, and so what's happening is the velocities are going to add together and it's going to make it go faster. Now, is it going to make it go as fast as the original one was before, the 0.85? No, it's going to go somewhere in between there. So we can just call that V final. And I don't know where that is. That's what I need to figure out. All right, so my IF charts, what they allow me to do is now I can look at this and I can set up my equation from this. Now the piece that is new is this 25 degrees. And so we know that velocity is a vector. and you can see the direction this velocity is going. Well, hopefully you also understand that if that's going in that direction, it's really only the v sub x that we need. We don't need the v sub y. That's not pertinent to us. So all we need is the v sub x. So let's just take a second to figure out, okay, well, what is v sub x? It's 25 degrees here, it's velocity here, so isn't it going to be, and I'll call that v sub 2, isn't it going to be v sub 2, and that's attached, so it's cosine 25. So that's what my v sub x is going to be. All right, so let's start to put this into an equation. Remember, the equation starts out as m1 v1 initial plus m2 v2 initial is equal to m1 v1 final plus m2 v2 final. And on the right-hand side, I could factor out the v because the v final is the same on both of them. So since it's the same, I can just call it vf, and then I have my m1 plus m2 on the inside. So that's my setup. That's what I'm going to do to figure out my answer. So if I take a minute to plug in some numbers, my first mass is 510 kilograms, and it's going at a velocity of 0.5 meters per second. Then I also have my second mass, which is going at a velocity of 0.85 meters per second. And maybe when I drew my VF chart, I should have maybe changed the size of this because it's not going the full 0.85 because we're only going to use the V sub x. So we need to include in here the cosine 25. So we're going to put times the cosine of 25 because that's really the velocity that we have. And so probably my chart wasn't exactly correct on that. So now we just need to do some calculation and see what this comes out to. Okay, so I put this in my calculator. I do some calculations. I find the cosine of 25, and I multiply all that. I add those together and divide by 660, and my final velocity comes out to be 0.56 meters per second. So not a lot of new information, but just kind of putting together some information that we already knew. Just having to remind ourselves we have to break that into components, remind ourselves how to use our IF charts to set up our equations, and then just put it into our calculator there. So most of the problems on this page are going to involve some of that. That is breaking things down into components, looking at the Y components and the X components and so forth. So that's what this worksheet's going to be about.